Okay, we will solve the next problem. The exercise says the Porsche engine exerts 229 foot-pounds of torque at 4,600 RPM. Determine the value of the torque in Newton meters. So the first thing that we have to evaluate here is that we are transforming force units. And because of Newton's second law, a force is given by mass multiplied by an acceleration. So when we are talking about US units, then we are talking about force pounds, which is equal to slugs, multiplied by feet per square seconds. So you can notice here that the slugs are going to be the mass units and the acceleration units will be the feet per square seconds. Then in the international system units, we will have newtons, which are equal to kilograms multiplied by meters per square seconds. So I'd like to do a clarification here, and is that these kilo are not the units, because the units that we're managing here are going to be the grams. The kilo are just a prefix that means 1 times 10 to the third power. There is a lot of prefixes. You can find it in a chart. Maybe you can Google it. Units, prefixes. And then and in that chart you'll find the kilo, mega, giga, etc. And on the below part of the chart you'll find decis, centi, milli, micro, etc. Now that I've made that clear, there is another concept that we have to take into account, which is the torque. The torque is given by a force multiplied by a distance. When we have, for example, a table, and we take the root as our central point of the table, and we applied a force, for example here, that force is going to generate a torque in the root of the table, at the root of the table. So that torque is going to be equal to the force, which is this one, multiplied by a distance, and that distance is this one. In order to for a torque to be applied, or to exist a torque, in order for a torque to exist, maybe that is the words that I'm looking for. In order for a torque to exist, it has to apply a force transversal to the area of the object that we are managing. So as you can see, this distance is transversal to the force. That is the principal thing that has to happen. Then, now that we've made this information clear, we can start to convert the units. So 229 feet, what was it? Foot-pounds. Foot-pounds. I already know that these pounds are referring to force pounds, because if this is a torque, then it's equal to a distance multiplied by a force. And we have to transform those into Newton meters. So we just have to play with the units. 229 feet per force levers, which is equal to slugs multiplied by feet divided by square seconds. Then I'm going to multiply this for me to eliminate the I'm going to write it in black, the feet, transform those into meters, then eliminate the slugs, transform those into kilograms, and then eliminate these feet by doing the same thing that I did here. What I could do is to get to the second power this division, and that would be like eliminating these two units. Let me point for you these two, and with this square. But I would like it to do it more simply, like simpler. So I just gotta multiply this again. As I said, I could get to the second power this division, but maybe it's not that clear. So 1 feet, I just have to find the equivalence between 1 feet, 1 slug, and 1 feet into meters, kilograms, and again meters. So I already know that 1 meter is equal to 3.281 feet. Then I just gotta find the equivalence between 1 feet. So that is going to be equal to 1 multiplied by 1 and divided by 3.281 feet. So 3.281 feet. And then I already know that 1 slug is equal to 14.59 kilograms. So 14.59 kilograms. And then the thing that I just did. And as you can see, the result will be in meters multiplied by kilograms, multiplying again by meters, divided by square seconds, which is equal to newtons per meter, or multiplied by meters. So in the calculator, I'll write down the whole equation. 229 multiplied by 1 divided by 3.281 divided by 1, and again 14.59 divided by 1, and again the feet conversion. And the result is 310.3689 Newton meters. Why is that? Maybe that is not that clear as I wanted to, because here we have meters, kilograms, and meters. So meters multiplied by kilograms by meters, and divided by square seconds. So as I've said before, this is equal to a Newton. And here we have the meters. So that's how this exercise could be solved.